there, my name is Dr. Marissa May. In this video, we're going to be talking about area and perimeter, and I want to start with this composite figure. I call it a composite figure because I want you to see that really I've got a rectangle, actually three rectangles joined together. And so we're going to deal with the area and the perimeter individually. So I like to use the first rectangle. I'll call that area 1. And then I'll look at the second rectangle as area 2. And then I'll use the third one as area 3. Now, the first rectangle you can see is 12 by 3. And I'm going to go ahead and multiply those since we find the area of a rectangle by doing length times width. So area 1 here would be 36 square meters. Now, if I do area 2, it gets a little bit dicey because I don't know this length. And that's important because I need that as the width of area 2's rectangle. So let's see if we can figure that out. I notice that this whole length on the top is 12. All of that is 12. But this little part right here is 7. So I have to think, okay, what do I add to 7 to give me 12? And that would have to be 5 meters. And that lets me know the width here. Now, I also need to know the length, this segment here. And so let's use the same idea. I know that the whole figure is 12 meters. And then I also know that this section right there is 3. And this section right there is 3. So 3 plus 3 gives me 6. And then if I add another 6, I'll get 12. So this area 2 is 5 by 6. And I'll multiply those together to get 30. Now let's do area 3. That bottom rectangle is a 15 by 3. We can multiply those together to get 45. And if we add them all together, let's see, 1 gives me 111 square meters. So the whole figure would be 111 square meters. But notice what I did is I actually broke it up into 3 different rectangles. Now, for the perimeter, I'm going to go ahead and just add up all the sides on the outside. Since we already found that 6 meters there, that was the only side that was missing. We are good to go ahead and add these all together. So I'm going to add the 12 plus the 12 on top. I'm working in a clockwise manner. So I've done 12, I've done 12. Now I need the 3 and the 7. So I'll add those. And then I need the 6 and the 10. So we'll add those. And then I need the 3 and the 15. And you'll notice I just marked them off as I went. And that helps me to keep track of which ones I've actually added together and which ones I need to add. So I'm going to do 2 at a time here. Makes it a little easier for me. You can just add them left to right if you want. Like I said, this just makes it a little easier for me. And that gives me 68. And this is meters for my perimeter. So I hope that helps you with a composite figure for the area. Remember, you want to break it up into shapes that you recognize and then calculate their area and then add them up. And the perimeter, then you'll go ahead and just add up all the sides. Now, I want to look specifically at the area and perimeter of some shapes. So let's take a look. First, let us begin with the area of a parallelogram. You can see that the area of a parallelogram is the base times the height. The height is kind of tricky here because the height has to make a right angle, a 90-degree angle. So if we look at the parallelogram I have on the left here, the base would be the 10 centimeters. And the height would be the 4 centimeters. I noticed that this is the height because I want you to see that right angle that's formed right there in the corner. So if I do the area, I would do 10 centimeters times my 4 centimeters. And that gives me 40 square centimeters. Now the perimeter is where I'm going to add up all of these sides on the outside. And things you have to know about a parallelogram is that opposite sides are congruent or equal. So that means that this is also a 10 centimeters and this is an 8 centimeters. So if I add those all up, 8 plus 10 plus 8 plus 10 will give me 36 centimeters. Notice I didn't use the 4, which was the height. I didn't use that in my perimeter calculations because it's not on the outside of the parallelogram. Okay, next let's take a look at the triangle. So for the area of a triangle, we get the 1/2 times the base times the height. I think that's important to remember that 1/2 there. If you look at my triangle on the left here, my base would be the 48 inches and my height would be the 14 inches. So if I want the area, I'm going to do 1/2 times the base times the height. So I'm going to be multiplying that 1/2 times 48 to give me 24. And then I multiply times the 14 to give me 336 square inches. Now the perimeter, I need the missing side here, which I want to kind of remind you, this is a right triangle. So in order to find that missing side, we can use the Pythagorean theorem. Now the Pythagorean theorem tells us that we square each of the sides and we add them together, and that should equal the hypotenuse squared. Now remember, the hypotenuse is the side opposite the right angle here, which is the side we're trying to find. So I'm going to let A be 14. I'm going to let B be 48. So 14 to the second power gives me 196. And then 48 to the second power gives me 2,304. So if I add those together, I get 2,500, which if we take the square root of both sides, we take the square root of that 2,500, of course, we'll get 50. So my missing side here is 50 inches. And now I'm ready to find the perimeter by adding those all up. So I've got 14 plus 48 plus 50. And if we add those up, I'm going to get 112 inches. Now, by the way, I am using a calculator on that. I don't expect you to be able to do all of those bigger numbers. So feel free to use a calculator if you need one. I've put one in the link below in the description below for the free online calculator available by Desmos. Next, let's turn our attention to circles here. Now, by definition, a circle is all the points that are equidistant from a given point called the center. Now, in our drawing here, C is the center of the circle. Then we have points that are inside the circle. We call those interior points. We have points that are outside the circle. We call those exterior points. And then we have points that are on the circle. So if I'm looking for a point that's outside the circle, we call it exterior. That would be point E here. This is an exterior point. If I'm looking for a point that's inside the circle, that would be point I here. That's an interior point. Then we have two special segments inside of our circle. One is the radius. This is a segment with one endpoint on the circle and one endpoint on the center of the circle. So this segment here is the radius. And then we have the diameter. This is a segment that goes through the center, but both endpoints are on the circle. So this segment here would be called the diameter. I have often heard it said that the word radius has 6 letters. The word diameter has 8 letters. That's why the diameter is longer than the radius, if that helps you remember those two. Now, let us turn our attention to finding area for our circles. Taking a look at our example here, we are asked to find the circumference. That's a big, long word that just means the perimeter of the circle, and we can find that by doing pi times the diameter, or we can do that as pi times 2 times the radius. So if I look at my circle here, you can see that my diameter, the segment that would go through the center and have endpoints on both ends of the circle, is this 10 millimeters. So my diameter here is 10 millimeters. That means that my radius would be half of that, or 5 millimeters. So if I'm going to find my circumference, I'm going to use the easy one. I'm going to use the pi times the diameter. Now, pi is a constant. It's a number that often is used as 3.14, although the digits go a lot farther, just so you know. Sometimes we might be asked to leave it in terms of pi, and I'll show you what that looks like. So pi times the diameter, my diameter is 10. So my circumference is 10 pi. If your question asks you to leave the answer in terms of pi, you would leave this. However, many times we're asked to use that 3.14 for pi. And so we can make that substitution here and multiply that to get 31.4 millimeters. Now remember, circumference is the perimeter of the circle. So we get just the standard units there. All right, let's turn our attention then to area. The area of the circle is pi times the radius to the second power. So you have to use the radius on this one, and we'll go ahead and make that substitution. Pi times the radius, which is 5, to the second power. Now, if that second power gives you problems, what I want your next step to be is I want you to multiply that 5 times itself twice. See how I did that so that I didn't have to deal with the exponent? If that helps you, please do that. Because, of course, 5 times 5 is 25 pi. And then remember, this is area, so it's millimeters to the second, square millimeters. Now, if we are asked to use that 3.14 as our pi, then we can get a decimal. And again, that gives me 78.5 square millimeters. 78.5 square millimeters. So definitely practice with the circumference and the area here. Use that 3.14 as our approximation for pi so that you can put it in your calculator and get your calculations that way. I hope this helps you with your calculations, area and perimeter, all different kinds of shapes. If you have questions or you want to see more videos like this, please leave a comment down below. Thanks, everyone. Bye for now.